Bismillah ar-Rahman ar-Rahim. We started Unit 6 few classes back, and so far we have talked about, if you go back to the first slide with the agenda, uh, Unit 6 will be covering three sections. The modeling of ROMs in Verilog HCL, this we talked about. We are now in part 2, modeling of sequential circuits, or we should say special sequential circuits. We talked about flip-flops. I think we're almost done with flip-flops if we are not actually done with them. We still have maybe a few more slides about flip-flops. Probably today we'll also start registers, and then we're going to talk about shift registers and counters. In the end, we'll be talking about modeling of any custom sequential circuit, or what it's called finite state machines. Yeah, so we talked about implementing D flip-flops, T flip-flops. We also mentioned flip-flops with additional inputs, which is the reset signal and the preset signal. We said there are two types of reset and preset signal, اللي هي asynchronous reset and synchronous reset. Asynchronous should act on the level of the reset, and synchronous should go with the clock. And we also saw how to code both, I think, both situations. What's the difference between this and that? Now here is a synchronous reset n, and we say as a convention we add the letter n at the end of the signal to indicate that this signal is an active low signal. That means if reset equal to 1, operate normally. If reset goes to 0, we need to reset the circuit. So um, this will affect our sensitivity list in case you are doing asynchronous reset. So any edge triggered, if the sensitivity list contains edge triggered signals like clock, all the signals in the sensitivity list has to be edge triggered. فلذلك we cannot write here reset. If reset changes, anyways, this will not compile. It will give you an error. So that's why we're going to use negative edge of reset. We will use negative edge of reset if you're using an active low reset, and you will use a positive edge of reset if you are using just an active high reset. Inside your always statement, first you're going to check on your reset in both cases, whether it's synchronous or asynchronous. If reset is active, you will set Q to 0. Okay. Of course, this is for an active high reset. If it's an active low reset, like the previous slide, you need to check if reset equals 0, or you can use not reset n. So both of these will achieve the reset. Okay, and if reset is not active, then you'll just take D into Q. تمام. هذا بالنسبة للفليب flops and what we talked about before. Also, we mentioned something about blocking and non-blocking assignments. Mainly, any sequential circuit should be using non-blocking assignment. Verilog will not give you an error if you used blocking assignment, but the way the circuit will be implemented is different than what we usually do. So let's take, for example, we have a system with two flip-flops. So that's flip-flop F and flip-flop G. And then we have the equation is F is equal to X1, X2, and G is equal to F or X3. Now, if you want to implement this circuit, يكون عندنا two flip-flops, F and G. This is F and this is G. The input of F is X1 and X2, so that's X1, X2. Input of G is F or X3, so this is F, and then we will OR it with X3. So this is what we did before, and this will be the clock signal. Do we have reset? No, we only have these. تمام. This is what we did before in designing any sequential circuit. We get the next state functions and we implement them. Now, Verilog will synthesize to this circuit if you use non-blocking assignment. If you use non-blocking assignment, this is what you get. Exactly how we designed sequential circuits before. What if maybe by mistake or by purpose you used non-blocking assignments? طبعا sorry, blocking assignments. A non-blocking assignment, this is the symbol for non-blocking assignment, and this is the symbol for a blocking assignment. Now, if you use blocking assignment, the synthesized circuit will look different. What it's going to do, and since you want the new value of f to be considered in the calculation of g, what Verilog will do, it will take this statement for f and it will plug it into, it will replace this f down here with this function. فبالتالي g, when you synthesize, it will change this f and it will make it x1, x2, or x3. طيب, does this and this اللي هي f of g, these two, is it equal to this circuit? Do you think?
لا.
لا. ايش الفرق؟ حيصير بدل ما اخذ f من هنا, what I'm gonna take is this signal here اللي هو x1, x2, and I OR it with f. I OR it with x3. So this circuit and the previous one are not the same. تمام. I think they have I think the circuit is somewhere. Yeah. So with blocking statement, this is what you get. It will take x1 and x2 and OR it with x3 to get you g. And if it's just the same, it's not using any left-hand assignment, فبالتالي if is going to be x1, x2. Okay, so you have to be careful and always use non-blocking assignment unless you know what you're doing, unless you want this behavior. Now, the same circuit can be written in non-blocking assignment as follows. If I want this circuit in non-blocking assignment, it's going to be different. I can write G takes on the value of x1, x2, or x3, and F takes on the value of x1, x2. Okay, now this with non-blocking assignment will synthesize to this circuit, which is not the same as if you use non-blocking assignment for these two. Anyone had a question? Okay. All right. So the main difference between blocking and non-blocking, قلنا إنه blocking assignment will evaluate the value of f first. It will update the value of f when you use it here in the calculation of g. Non-blocking assignment, لا. If you use non-blocking assignment, let me clear that. So if you use non-blocking assignment here, the value of f that will be used in the calculation of g is the one that was stored before you enter the always block again. It's the one from the previous cycle. If you have a clock this way, now what's in your sensitivity list? It's positive edge of clock. So at every positive edge, I will be evaluating f and g. For using non-blocking assignment, let's say after the first edge, here the value of f is equal to 1, value of g is equal to 0. Now, for the next positive edge, when you calculate f, let's say x1 and x2 equal to 0, 1. بالتالي f should take on the value of 0. Now g, when you calculate g equal to f or x3, using non-blocking assignment, this will make it g is equal to 1 or x3. Okay, it's going to take the previous value of f, not the updated value of the current cycle, which is how sequential circuits work. Okay. طيب, what do we have here? Both if and G are implemented out with D flip-flop synthesized. This is what we talked about. That's just explanation of what we mentioned. And this is the synthesized circuit with blocking assignments. Now, if you use non-blocking assignments, which we already mentioned, make sure that this symbol is less than or equal, meaning a sign. Um, just as we mentioned that G will get the previous or old value of F. It will not take the updated value of the current cycle. Okay, and that's the circuit that we drew first when we wrote the equations. Okay, the value of F will be routed to the input of the next flip-flop. Right, so if I give you a code and I ask you to draw the circuit that Verilog will synthesize to, you have to clearly and carefully read the code to make sure are we using blocking assignment or non-blocking assignment, because the resulting circuit is not going to be the same. Okay. Now the next few slides is just a repetition of the code that was mentioned before. This is a D flip-flop for with asynchronous reset. If it's asynchronous, you have to put the reset in your sensitivity list. Depending on if the reset is active low, you're going to use negative edge. If you're using active high, it's not here. Like if you're using active high reset, this should change to positive edge. Now for synchronous reset, the sensitivity list will not contain reset. We will only check reset when we enter the always block. Okay, so that's synchronous active low reset and asynchronous active low reset in these two slides. Both were mentioned before. Right. Now we're going to move into the next part of section 2 of unit 6. We'll be talking about registers and counters. Now we covered register and counters from logic design point of view in unit 2 thoroughly, and we'll see how to write the code, how to write Verilog code to model these register and counter. Quick revision on a register. What's a register? A register is just a group of flip-flops. All will have a common clock input, but it will have different data input. And it should also have a common reset signal. So you have common reset, common preset. Imagine that you have a preset here. All these has to be common as well. Any special signal has to be common between all flip-flops inside this register, and a common clock and a common reset. It will have different data input and different data output. Okay, and mainly the register is used to store binary data, and you can do some type of operation on registers like shifting, loading, serial input, serial output. All of these can be done using registers or special kind of registers. Okay, so note that in the register, all the flip-flops are connected in parallel. That means you can load data in parallel and you can read data in parallel as well. Now, what do you need to create a register? You just need n-bit. For an n-bit register, you need n D flip-flops. You want to create a 4-bit register, you need 4 D flip-flops. If you want to create 8-bit register, you need 8 D flip-flops. Okay. Now, how to model a register? That's quite easy and straightforward. We will make a 4-bit register with asynchronous clear. Okay. When you read asynchronous clear, synchronous reset, synchronous preset, you have to يعني make extra take extra caution when you write the code, because this will alter your code. Now, for a 4-bit register, we have input D for data, we have clock input, of course, and we have a reset N, that means this is an active low reset, and we have Q for the output. Now, my input D is 4-bit, clock and reset is single bits, and Q is an output of 4-bit. Now, don't forget to declare this as a rig as well, output rig, because the value of Q will be changed and updated inside an always block. And anything you do inside an always block, you should get, you should declare it as a rig. I think there is something missing in this code. This should have begin and end here. Okay. Now, since this is an asynchronous reset, I have to add it to my sensitivity list. And I'm going to access my always block at the positive edge of clock. Now check if reset equal to 0. That means I want to reset. So let Q equal to 0. The output of the register will be 0. Else, that means we are not resetting. Just read whatever you have in D and put it in Q. Important to note here that we are using non-blocking assignment for that. Okay. Now, for the same code, we can use the same code, but make it a general implementation. So we're going to define parameter n, and by changing this value of n at the beginning of your module, you can make any sized register. But you should give a value. في البداية, you should give a value 16, but if you want 8-bit register, come to the code, take this 16 out and put 8, for example. This will make you an 8-bit register. تمام. For everything after this line has to be in terms of n. Everything here has to use n. Don't depend on this 16 at all, because the point of using this parameter is to make this code general. Now define the input from n minus 1 to 0. So if I have 16, that's going to be 15 to 0. If I have an 8-bit, this should be 7 to 0. If I have 4-bit, this should be 3 to 0. The output is going to be the same size. So output rig from n minus 1 to 0. And these two signals are common between all types of or any sized registers. And then you can see that the code is exactly the same. Don't forget that this has to have an begin end. Now, if this is an asynchronous active low clear, that means I need to use negative edge of reset n inside my sensitivity list. Check for the value. If that equal to 0, or sorry, if not reset n, that means reset equal to 0, make q equal to 0. Now note here the difference between this line and that line. Now here q will take on the value of 4-bit 0000 exactly. If q is declared as, let's say q here is declared from 7 to 0, معناته q is 8-bit. What this statement will do is that it will only clear the lowest bits of q. So if q is 8-bit, 1, 2, 3, 4, 5, 6, 7, and 8, this statement will set zeros here. These will be kept the same. So that's q4, q5, q6, and q7. This will keep its previous value. فمعناته this reset will be incorrect if you're using the same code in here. فبدل ما اكتب q takes on the value of 0, I write q takes on the value of 4-bit 000. This will be incorrect. This will only reset the lowest bits of q. So what you do, you don't need to put a size, just put a decimal value of 0. This will make all the bits of q 0, because this is a decimal value. Here, no, this is a 4-bit binary value. Even if we write equal to 4 or مثلا 4 bit decimal 0, now that is the same as this. It will also be 4 bit, which is incorrect if you want to use it for يعني generalized register. Okay, so that's why I put 0 here without any sizes, so it will just take on the size of Q. Now else, if we're not resetting, load the register with the value of D, so D will be taken into Q. Okay, so again, this is a general code for an n-bit register having an asynchronous clear, and that clear is an active low signal. I can ask for the same code, but I can write with synchronous active high clear and preset. Okay, I added two signals, clear and preset, but these are synchronous, so you have to take it off the sensitivity list, but you still have to check them inside your always block. Okay, make sure you understand that clearly. Okay, what do we have here? We have an n-bit register with asynchronous clear, active low, that's the same code. What's the difference? Ah, okay, we have an enable signal to this register. So let's say you have 4-bit, so you'll have 4 input D and 4 input Q, or 4 output Q. I have a clock signal. I have an active low reset. We'll call it reset N, and I have an extra input called enabled. So the point of enable, like if enable equal to 0, ignore all these signals. Ignore the clock, ignore reset, ignore D, and don't change Q. Okay. If enable equal 1, just behave normally. So we will have exactly the same code as before. This is the same code in here, but I will add an extra input called E. This is short for enable. Since the reset is still the same, that's an asynchronous active low reset, I'll have it in my sensitivity list as a negative edge triggered signal. Inside, I will still check for reset. That's the same. Now, in the previous code, I just said else Q takes on, Q will take on the value of D. This is the one in the previous slide. Now, I need to consider the enable signal. So else if E is equal to 1, Q will take on the value of D. Now, this circuit is not the same as I just explained. Can anyone tell me why?
الإلس الثانية يا دكتور.
ليش؟
الإلس
ايوه ايش
إذا
بقى؟
كان الانيبل 0
مهم.
المفروض نكتب إلس.
لا انا هنا ايش قلت؟ قلت انه if enable equal to 0 do nothing, ignore all the signals. تمام؟ لكن this code is not exactly what I just said. ليش؟ لانه if افترض reset equal to 0, now at negative edge of reset it will enter the code, it will check if reset equal to 0 and it will set Q equal to 0 بغض النظر عن value of E. So this implementation you have in this code, the only thing it will disable is the loading from Q to D. But if reset is active, it will do the reset. If you want to implement the code for equal to my explanation, انه enable will affect all signals, I have to change this part to the following. I will say if enable begin Now inside here I will check for if reset or if not reset n. If not reset n, q takes on 0, else q will takes on d. Okay, now this code, everything depends on enable. In this code, no. It has, like here, reset have a higher priority than the enable signal. E synchronous. ما فهمت يا عبد العزيز. E synchronous. ايوه E هنا تعتبر synchronous signal. That's fine. If you want E asynchronous, you have to come back to the sensitivity list. Okay, but E doesn't have to be synchronous, an asynchronous signal. Okay, so just to go over the difference again. This code enable have the highest priority. If enable 0, الفليب فلوب ما راح يستقبل اي اشارات لا clock ولا reset ولا load. This code here, it will load or will enable will only disable the load. If enable equals 0, it will not load. ولكن reset, it will work even if the enable equals 0. From my understanding, this is incorrect. Enable should be top priority. But anyways, both designs are fine. If there was no إذا كان في سؤال وما تحدد البيهيفير اللي شرحته الآن, that's fine. If you use that, this is correct, and if you use this, this is also correct. Okay, so that's all about registers. It's easy. Register only will have any special signal, سواء كان reset, preset, enable, and you either load the value of d أو إنك you load 0 if reset أو you load 1 if you want to set, and you can also add an enable signal to that. Right, so now let's move on to shift registers. Shift register is just a register that is capable of shifting the values among the line of registers, سواء you want to shift right or you want to shift left. So we know this implementation from before. If you connect these flip-flops this way, now this is Q2 and this is Q1. D will be considered the serial input to this shift register. And for each cycle, Q2 will take on the value of Q1, and Q1 will take on the value coming from D اللي هو serial in. تمام. if you have a number Q2 and Q1, if Q2 is taking Q1 and Q1 is taking D, is this shift right or a shift left operation?
Shift left.
This is a shift left operation, yes. So the new value, it's going to be Q1 here and then the value of D here. So what you did, you shifted left by 1 bit. So let's check the code. We have module shift. I have input D. I have a clock input, Q1 and Q2. These are the output of the flip-flops. So I declare input D 1 bit and clock 1 bit as well. Output rig Q1 and Q2. These are the value that we're going to update inside the always block. So that's why it has to be an output rig. And then always add the positive edge of clock. Go inside and just write the statement that we just explained. So Q2 will take on the value of Q1 and Q1 will take on the value of D. Now, does the order matter here? If I write Q1 takes on the value of D, أو I mean if this one أو إني كتبتها بهذا الشكل, Q2 takes on the value of Q1 and Q1 takes on the value of D. Compare this to
ما يفرق.
ما يفرق. ليش؟
non blocking ما يفرق.
صحيح. Non blocking will not make a difference. إذا كتبت Q1 equal to D, Q2 equal to Q1, هذه وهذه is not going to be the same. Okay. If you use blocking assignments here, these two will not be the same. So always remember to use non-blocking assignment unless you know what you want. Okay. More information about shift register. So usually a shift register will have a clock input. That's a must. You will have a serial input, serial in, and you'll have a serial output, either called serial out. This is the same as this is in case you want to catch these bits that are coming out of your shift register. You can also have n parallel outputs. You can read the output of all bits in your register. And also you can have actually a serial, not serial input, you can have parallel load. Parallel load معناته عندي input from D0 to Dn minus 1. I think one of the homeworks we did uh, a register that can shift right, shift left, hold, and does it have parallel load? I don't remember. ولكن الفكرة إنه each register will have should have a mux at the input to choose between these operations. Now this register that this slide is talking about have the following features: blue serial in, and it have a serial out. That means we are catching the bits that are coming out of our shift register. Then if you remember shifting, there is one bit that you're going to ignore. فمثلا if I want to shift right this value by 1, the result of this operation is 0, 1, 1, 0. This bit here was thrown away. تمام. If I have serial out, like if serial out here is going to another special flip-flop, تمام, I can catch this bit by adding this flip-flop here. تمام. Anyway, serial out is just equals to the last bit in your shift register. This is for a shift right. Is it shift right or shift left? If serial in is coming to Q0, this is a shift left operation. So this will be the most significant bit of your register. طيب, if you add parallel output to your design, like you allowed to read the value of from Qn-1 to Q0, this whole circuit is called a serial to parallel converter. Make sure you know what this means. Serial to parallel converter means that I will apply serial input to my register or to my shift register, and I can read out the value in parallel. Can you give me an example of where this can be used? Serial to parallel converter. This is something that I'm sure like everyone is using on a daily basis. So this circuit is used in your USB. USB is short for Universal Serial Bus. If you crack open your USB cable, you will find how many cables is in your USB. Do you know? Let's say USB 2.0. يا جماعة اليو اس بي كم سلك؟ You never looked into an USB before?
فتحت يو اس بي حقي ما فيها سلاك يا دكتور.
يا رجل بدون اسلاك وايرلس.
والله ما اشوف شيء.
If you take a look at يعني الكونكتور of the USB, you will find 4 lines. في 4 lines 4 خطوط. ايش صار؟ طيب عندنا اليو اس بي we have 4 lines inside if you cut a USB out, you will find 4 wires inside. Usually red, black, these are commons, and then 2 more colors that يعني I think it can be different. ولكن red and black is pretty common. So one of them is used for the power supply, which is the plus 5 volt line, and this one will be ground. الأسود ground والأحمر plus 5 volt supply. There are 2 other lines here. This is for positive data, and this is for negative data. This means one of them will pass data from your device into your computer او العكس من your computer to your device. فالان الداتا عندك مسجله مثلا في الميموري حيكون عندك number of bits. مثلا if you are working on a 32 bit machine, this register is 32 bit. If you want to send this 32 bit to your device here, اعتبر انه هو هارد درايف مثلا، عندك هارد ديسك خارجي وتبغى ترسل الباكيت هذا اوف داتا 32 بت to the hard drive. الهارد درايف حيخزن هذه 32 bits in its memory. تمام. If you want to transfer it right away, تحتاج you need 32 wires to do that. طبعا زمان كان في بورت اسمه البارallel بورت، اعتقد كان في 36 بنز، يعني في له 36 سلك. حق الطبعات القديمه، اذا في احد عنده طابعه قديمه في البيت حيلاقي بورت كده كبير جدا في له حول 36 سلك. It can transfer I think 18 bit at a time، ولكن كان parallel transfer، يعني كل سلك will carry 1 bit. It was huge and expensive for nothing. So what USB does اني طبعا اليو اس بي هيعكس السيركت هذه، حيكون في سيركت no is it the same? Yeah, I think that's going to be the same. So from this register it will take serial out تمام and start passing serial out to this wire bit by bit. At this end of the USB اللي رايح للهارد درايف تبعك let me erase. Now I said we have 4 lines. تمام، هذا اللي هو السبلاي. This is the ground. Now at the end of the hard drive الهارد درايف بيستقبل الداتا هذه كيف؟ serial. جايته serial in من your PC أو from your device. To save this data into the hard drive، الهارد درايف الكنترولر تبع الهارد درايف لازم يكون عنده سيركت نفس هذا اللي أمامكم بالضبط. It will take this serial in and start shifting the value inside the storage element. After few cycles تمام if this is 32 bit it will take 32 cycles to complete. After the 32 cycles your data is stored in your hard drive. Okay, if you want to read it in parallel you can also do that. ولكن this circuit اللي هو يكون عندك serial in and serial out, this is used for any serial data transfer. So this circuit what it does, it converts serial input to parallel output. What if you want to create parallel to serial converter? What modification you need to do for this circuit? جبت لك سؤال قلت لك ابني لي 8 bit parallel to serial converter. سؤال سطر واحد فقط. Now parallel to serial converter you will make a register. خلينا نقول 4 bit register. This register has the capability or has to have the capability of reading data in parallel D2 D3 depending on a signal called load. This is something that we have done before. So this signal load will load this value into the register ولازم يكون عندي serial output so I can read out the data in serial. Parallel to serial converter will read data in parallel and it will take out data in serial. A serial to parallel converter will take data in serial and it will take it out in parallel. Is it clear? Any questions or any points of confusion regarding serial to parallel and parallel to serial converter? I think we have parallel to serial here. Yeah, so it went right away to a 4-bit shift register with parallel load. Okay, so description of the circuit. All actions take place at the positive edge of the clock. This we already know. Now, this register will have a special input called L, and it's short for load. So if L equal to 1, the register is loaded in parallel with the 4 bits of input R. This is the same circuit I did here, ولكن هذه بدل ما سماها دي سماها R. Okay, so we have 4 input signals, vector R, and if L equal to 0, that means we are not loading, the contents of the register are shifted to the right, and the value of the input W is loaded into the most significant bit Q3. So meaning this W is the same as serial N. Okay, so you're shifting in some value W if you are not loading. Now how to write the code for that? Make a module. I have R, this is for my parallel input. I have load, this is, I have L, which is my control signal load. I have W, which is my serial N signal. I have clock, and I will have the capability of reading the output in parallel, which is the output of the flip-flops. Even if you're not reading in parallel, you have to have Q because you're connecting these flip-flops together. So you have to have value for D and value for Q. Okay, declare R as 4-bit because did it mention 4-bit? Yeah. So here it was asking for 4-bit register. So input R will be 4-bit. Single bits, we have the load control, we have serial N, and we have clock. Output reg is 4-bit of Q. Now, there was no mention of any special signals اللي هي reset or preset, so we don't have that. So my sensitivity list will contain only positive edge of clock. Now, if L, that means if I want to load, Q will take on the value of R. This is parallel load. Apply R at the input, read it to Q. Else, that means L is equal to 0. And if L equal to 0, we should apply whatever was described in this text. What we want to do is shifting right and load the most significant bit with W. Now, when you shift right, what do you do? Q1, Q0. If you want to shift right, that means Q0 will take the value of Q1, Q1 will take the value of Q2, Q2 will take the value of Q3, and Q3 will take the value of your serial N. In our case, serial N is W. So that's what you do. You write Q0 takes on Q1, Q1 takes Q2, Q2 takes Q3, and Q3 takes W. Okay, as easy as that. You can do the same code if you want to shift left, but if you want to shift left, you're gonna inverse everything here. حتصير بالعكس. If you want to shift left, write your number, that's Q3, Q2, Q1, Q0. If I want to shift left from here, that means Q3 will take Q2, Q2 take Q1, Q1 takes Q0, and Q0 takes W. So the code will be Q3 takes on Q2, Q2 takes on Q1, Q1 takes on Q0, and Q0 will take W. If you just replace this block with this block, you get yourself a shift left register. And you can do all kinds of stuff like we did in unit 2. You can have a shift register with parallel load, and it can shift right to left. You can have all kinds of register. All you need to do is make sure inside your always block you have all your control signal in an if else fashion او انك تستخدم case statement. You can write case L and then if this is equal to 0 do that, if that's equal to 1 do that, or maybe you have two signals. um, I remember one of the questions in the homework we had a register that will do four operations. I don't quite remember what the operation, ولكن كان في hold, كان في shift right, كان في shift left، ماني فاكر
كان في
ايش اخر.
parallel load بعد.
كان في parallel load. Okay, so
إيه.
parallel load. So make sure you have signals for all of that. You need 2 bits selection, and using case statement you can have these four these 4 combinations. Okay, هذا بالنسبة لي shift register. When you synthesize this code, this is what you get. You will get a mux depending on the signal load. If load equal to 1, then read from, it should be named as R3, R2, لا, R2, R1, and R0. So if shift equal or if load equal to 1, you will read this input. So this will give you a parallel load. Now if this signal equal to 0, تمام, check the most significant bit. الآن هذه Q3 وهذه Q2 هذه Q1 هذه Q0. Q3 will read the value of serial input اللي سميناها W. Q2 will read Q3. Q1 will read Q2 and Q0 will read Q1. Okay, so this is the synthesized circuit of the previous code. So make sure when you read a code, you should have knowledge on how to convert that code into circuit, or if I give you a circuit, how to make it into code. Next, next class we will talk about. We did tutorial for Unit 5, right? We did that. Yeah. So next class we'll continue on Unit 6. Okay. Any questions?